All right,
So,
all yours.
thank you. So, thank you everybody for joining this session. I'm DJ Das. I'm founder and CEO of Third Eye Consulting Services. We are a big data consulting shop here in the Bay Area, California, and we have been working with Microsoft for past 3 years now. This project, Crime Analysis and Prediction System, was actually created for the public safety and national security group at Microsoft. This group is headed by Sanjay Jacobs' team. So the specs came from them. They actually had got us 2 subject matter experts from NYPD to help us understand this. We were not the subject matter experts on crime data, but we were big data people. So we kind of got our arms around crime data, understood how to analyze and work with crime data thanks to the support of this team. So now, let's go over the problem definition. What does this system actually do and solve? The public governments around the world have a pressing need to now do more while spending less. Every government across the world, and I've spoken to at least 11 of them, various government bodies across the world, they all say the same thing. They need to do better with their existing people that they have on board. They need to be proactive in battling crime. And most importantly, they have to be at the right place at the right time so that they can beat crime as it happens or as it's about to happen. That's the premise, or that's the background around which the system was built. But the challenges that the government faces are quite a lot. They actually do not have so much resources who have, or so many resources who have an understanding of the technical stack that needs to be set up to get this system running. They don't even have access to the right data sets. The data sets are being generated and they might have siloed, but there is not a consistent or comprehensive view of all the data sets that are available. And more importantly, they do not have the latest infrastructure. Most of it is outdated and needs to be revamped. So these are the typical problems that governments across the world have been facing. So for helping that, along with Microsoft, Third Eye built the system which leveraged the open data initiatives. The US government has done an excellent job on the open data initiative. We have some tremendous data for the cities of Chicago, San Francisco, and New York, just to name a few. And I'm not trying to plug in Microsoft here, but definitely Microsoft has got a very good stack of big data technologies that are capable of handling all the various needs and demands of big data. And best of all, Microsoft big data technologies, they fit so easily with an existing infrastructure. Most of the government bodies are running Microsoft technology in some way or the other. And this technology stack of big data from Microsoft completely fits into that. So typically, with a click of a button, they can actually go from a regular SQL server that's running on that system on the premise into the cloud or into an on-prem SQL Azure. So the system, what it does is it analyzes, detects, and predicts about crime. The most important thing here is that it collects various kinds of data from various sources. We have crime data, we have US Census data, social media data, traffic data, weather data, and others. More of this a little bit later. And we are using both the Azure Cloud and on-premise technology to make it all happen. The system helps the local police in many ways. Number one way is the system can alert whenever a crime is imminent or just about to happen in the next 4 hours. The police can run the system to understand and predict where they should deploy resources, because that's the most expensive part of running a police organization. Now, with that, now let's dive deep into the technical section for this system. You will see that the technologies that we have used goes across the Microsoft stack: HD Insight, MapReduce, Hive, Stream Analytics, Azure Storage, SQL Azure, and the whole Power BI stack. Let's talk about the data collection layer first. What you see here is the capability of the system by which they could get data which could be static, real-time, or IoT, which is both real-time and static kind of data. So we have the open data, that is the static data that we get from various government websites. We have the crime data, which is also something that we get from US government websites. Census data, which is from the US Census government website. This system can extend to add any more data types that we could have. For real-time data, we have weather data that we are using from MapQuest. Forecast.io. Traffic data that we are using from MapQuest. We have social media data, both Twitter and Facebook. And going forward, the system could be extended to use other kinds of real-time data. The IoT data is still not yet part of the system, but we could extend the system so that it takes care of the Internet of Things data also. So the other kind of data sources that various police departments have told us that they would like the system to be integrated with is video data, images data, and police system data. So if the system actually gets a feed of all this data, which is of course would not be a public data but would be completely dependent on that police department. Now let's talk about the most difficult section of this project, which is how we collected the data. First of all, what we did was, for collecting the real-time data from Facebook and Twitter, we created a geofence around Chicago. Since this particular system was using the open data from the city of Chicago, we kind of did everything for the city of Chicago. And actually we are in conversations with Police Department of Chicago for taking this further for the city of Chicago. So every tweet has a location information in it. Maybe a user profile information which has a location bit, or the tweet itself will have a location bit. So based on that, we would compute the geographical location of that particular tweet and see what kind of data is it. The most important aspect here was to analyze the data that's coming in from either Facebook or Twitter, understand the aboutness of the data. If this data is about is about crime, then it's of some meaning to us. That's when we analyze the data further. We then try and find out what type of crime is this tweet about, or is this Facebook status update about. If it's something that we can analyze and use, that's when we save it in a SQL Azure database. So mind you, the most important thing that we were doing here was making sure that Twitter or Facebook data is about crime. Once we know it's about crime, we were trying to categorize it to a particular crime category that we could further use to analyze the system. Everything would get stored on a Azure SQL system. So now, one of the issues of this project was that we were mandated to use everything that's publicly available, nothing but whatever is available for the common man on the streets. So for that, when we were running the Twitter APIs and everything else, we had to work with the freebies, not the paid Twitter APIs. So we didn't have access to the paid Twitter feed. but we had access to the free Twitter feed. So for that, there are various limitations. For example, you could only download X amount of tweets in Y amount of hours, but beyond that, you cannot download anymore, or you cannot access anymore. You'll have to wait for a certain amount of time before you can access some more. So that's why we had to kind of create some kind of a scheduler that would wake up and run as per the demands of that particular API. For example, for the Twitter API, it could collect the amount of tweets it's allowed to collect in a particular time interval and then wait till the time interval passes over to the next level where then it will start collecting again. So that was a limitation, so to say, but if this system gets into the hands of any public government body, then of course they will have access to the full Twitter feed and or the Facebook feed, and such issues will not then be of any matter. So we heavily used Sqoop to migrate the data from the storage into the Hive table through a SQL Azure databases. Then comes to how we were presenting the data. This is the most important part, because no matter what kind of analysis you do, no matter what backend mumbo jumbo we are doing, if we cannot showcase the data in a proper manner, then it's of no use to anybody. So that's why the UI layer had to be very, very sophisticated. And thanks to the latest Power BI tools from Microsoft, we got some amazing results. We used Power Pivot as our semantic layer. Most of the graphs and charts were in Power View. We also used Power Q&A, Power Map too. Let me quickly talk to you about the system architecture. There are two forms of this architecture. One is cloud-based and the other is hybrid-based. I will explain the details of both of them. Governments across the world are not very comfortable with having all the data in the cloud, but they do understand the advantages of using the cloud. That's the reason for which we had to come up with a hybrid model so that most of the things remain inside the premise, but on a needs basis, whenever they have to analyze something, whenever they have to compute something which is beyond the capabilities of the current private cloud, then they would burst into a public cloud and perform those activities. That's why we had to come up with some kind of a hybrid model which would migrate effortlessly from an on-premise infrastructure to a cloud-based one. And on the cloud too, it could be either a private or a public cloud, doesn't matter. It would behave the same way. So going in from the top, yeah, this is kind of top-down kind of diagram. So data sources, both real-time and static, were collected using some C# custom code. Microsoft has got a new technology called Event Hubs. That's more like a queue that we have normally seen in the open source world. So this queue helps us to collect data faster than the rate by which we could write the data. So since the real-time data sources might be coming in at a rate which would be higher than the rate at which we could persist the data, we needed a queue mechanism in between. And Event Hubs gave us that queuing mechanism by which it could queue up the data that's coming in that we were ingesting, and as the system was writing into the HDFS, it could queue them up. I want to give you a brief update about Storm, which is an open source product. It's got a spout and a bolt. I'm assuming that you know a little bit about Storm at least. I'm not going to get into the details of Storm, but the processing part of it was mainly done in the Stream Computing Platform, which is Microsoft's version of Apache Storm. Primarily, Storm consists of three things: a topology, a spout, and a bolt. The topology defines as to how the whole system is going to work, what's going to come in, and what's going to be processed, and how it is going to be saved. The spout is the one that does most of the reading part. So primarily when the data was coming in from the event hub, it could get into a spout, which would be reading it off, and then handing it over to a bolt, which would process it. So the processing here would be, first of all, understanding the aboutness of a tweet or any data that's coming in. And then once we know the tweet is about crime, categorizing that. This component of categorizing was the most important component because crimes in various data sources were defined in different categories. US Census data had crime defined as a different categories. For example, they didn't talk about other crime categories that we normally found on the Twitter data. So there had to be a commonality between the various crime categories that we got from various data. And that was the most difficult part, because without that common linkage, it would be impossible for us to analyze and hook up the data together. So we developed some in-house lookups which would map various crime categories together. We took the help of subject matter experts to make sure that our lookups were all proper, so that no matter what data source we get, what crime category it produces, they all match up to an internal crime category which would be common across all data sets. So all these things were performed at the data processing layer. They'd all get then persisted to the HDFS and blob storage. Then comes the analytics part. We would have typically MapReduce functions that would analyze the data for whatever queries that user would have. We also wanted to do something on Hive, mainly because Hive is easier for people to use. They could just write a SQL query. They don't have to write MapReduce code, but using SQL query, they could get back some answers. But the problem that happens is that Hive or MapReduce, they take a lot of time to actually get back to you. It doesn't matter about the volume of data that it has to compute, but it takes a standard amount of time to do the computations because it's a batch processing mode. So it's not very suitable for an ad hoc services or ad hoc querying. So what we had to do was we had to persist most of the responses for most of the common queries into a SQL server, which could either be on-prem or on the cloud, and then have the Power BI go against it, so that whenever a business user was accessing the Power BI dashboard, the response time was very less. They didn't, I'm sure most of the business users wouldn't have the capacity or the patience to wait for 2-3 minutes before a MapReduce job gets back to them. They typically want the answers now and very much correct. So that's why we had to bring in a caching mechanism in between, which was either SQL Server or SQL Azure based on the demands, and would cache most of the responses for the queries. And this caching server would be updated on a 10 or 15 minutes interval time frame. I quickly wanted to go over the various data sources that the system had and the links to those data sources. This deck would also be up on the website, so you will have access to all those links, so you'll know what data sources we were working with. Now, let's get into the analytics part. I want to show you as to how the backend worked, how the various things came together, and how the analytics were looking like. I also had them in a PowerPoint just to be sure that if the demo gods don't agree with me, then at least I would have something to show you in a PowerPoint. But for now, I would like to attempt a real-time analytical section here so that I could show you something that's happening as it happens. So right now you see we are on Office 365. I have a site that we have created. This is what was built for them. and we have a Power BI Q&A section here. For those of you who are not very sure about Power Q&A, I personally think Power Q&A is one of the most powerful analytical tool that Microsoft has come up with. It allows the user to ask simple questions in plain English. For example, right now you can say show crime by year. If you type this question in this bar, then it will automatically generate a map for you or a chart for you. You could then change the kind of chart you want to have. You could say a line chart or pie chart, doesn't matter, and it just does it automatically. So what this chart tells me is that crime has been decreasing in the city of Chicago over the time. So from 2008 till 2013 is when we had the last data. So crime has definitely decreased during that time frame. If I have to look the crime by year and on a category, this is the crime category that I was talking about. So you see the query, it's a simple English type query. I mean English language type query. It's not a SQL query. So you're asking to show the crime by year type and the category as a line chart. So on the x-axis we have the time in years, and on the y-axis we have the number of crimes in thousands. What you see here is that crime has been decreasing for sure, but you will see that property crime is still so much higher than everybody else. All the other kinds of crimes, property crime is still so much more higher. We should find out more about it. Now, let's look at the crime by location for Battery for 2013. I'm sorry, the data that we have is only till 2013. We didn't update this data. So right now in the open data site of Chicago, they do have data for 2014 also. But when we did this project last year, they didn't have data for 2014. So we went with the last best data. So in battery crime type or battery type of crime for the year 2013, these are the locations where battery happened the most: apartment, sidewalk, street. And you are just asking a simple SQL English language query to see these graphs. If you want to see the various kinds of violent crime by year and crime type, you would again see that battery has not decreased as much. All the other type of crimes have decreased. This is the assault crime in orange. It has decreased. All the other kinds of crimes have decreased, but you would see the battery crime really has not decreased as much. What would be the reason for that? Let's drill down further into it. This is bubble chart. Again, a very powerful tool from Microsoft, which enables you to see the various trends of various kinds of crime over temperature. On the y-axis, we have the temperature. On the x-axis, we have the number of crimes. And what you see in these bubbles are the various types of crimes. Let me run this animation. So what you're seeing is how various kinds of crime trended over time. It may not be very clear to see, so let me just do a control click on all these various crime types, and you can easily see how they trended over time. So apartment crime, meaning crimes in apartment, were really on the high no matter what temperature it was. So if I run the animation again, you'd see how crime builds up. Note something very interesting here. That is, let's compare between sidewalk and apartment crime. What you see here is that as the temperature increases, the crime on the sidewalk also increases. And in an apartment, as the temperature decreases, the crime also decreases. So there should be some relationship to this. What we found out was that crime is done by human beings, and human beings have some very typical patterns, and that's what this data is telling us. For example, when it's summer, when it's warm, people are outside, lot many people roaming outside, lot many people walking outside, doing things outside, so, and various criminals also find it much more easier to commit crime during those times. But when it's winter, when not many people are outside, they typically tend to be in a house. And we have data which from the US Census data which can show us like the number of people who live in a house, if it's higher, then domestic violence goes higher. I don't have the chart right now for some reason, but we do have the data which proves to us that the crimes in winter, when people are typically higher, go at a much higher rate when the number of people in the house are higher. It just so happens that when people are close to each other, they are more open to some kind of altercations that leads to some domestic violence crime or something like that. So basically, this gives us the ability to understand and analyze various effects of crime and how and why it happens. Actually, I had the opportunity to present this at the World Partner Conference of Microsoft, which was held last year in June at Washington, D.C. And after my presentation, a couple of people from various police departments, they walked up to me and told me that our knowledge about crime is equivalent to a 10 to 15 year experience veteran there. And we were just 3-4 months into the project. My point here is we were not subject matter experts on crime. All that we did was analyze crime data, and we kind of found patterns and how crime was affected by various things and why crime happened. So just by looking into data, we became experts on crime. And going forward, I'm hoping that we would have more such opportunities to look at various other crime data so that we could extend our knowledge. I now want to show you how we went to the prediction part of it. Okay. So whenever we had to run a prediction on the crime, we had to base it on certain factors. So these are the factors that we took in. There were some assumptions here. I want to tell you first of all that our algorithms were not perfect. It's all those predictive algorithms, they can never be perfect in the first time. It has to be an iterative exercise, and then we kind of get closer to perfection. But for this project, this algorithm that we did last year, they were not perfect, but I'm sure that over some amount of time, as we iterate more and more, we'll achieve to be more closer to perfect reality. What we did was, whatever we predicted, we then kind of actually compared it with actual data from the city of Chicago as and when it was made available on the open data website of Chicago. We compared our forecast with whatever actually happened. We found out that we were way off sometimes. Sometimes we were close, but then that gave us the further impetus to actually work on our algorithms better to make it happen. I'm sure within this year we would be in a position where our algorithms would be much better and more closer to what it actually happens in reality. So some of the factors that we considered here for predicting crime were as follows. We have the community ID. It's basically the area. What kind of area we are talking about? Of course, the date, and then the time period. We kind of created 6 categories of time on a daily basis because we felt that that way we could categorize the crime happening much better. For example, the kind of crimes that happened between 12 a.m. and 4 a.m. were very much different than the kind of crimes that happened from 8 a.m. till 12 p.m. So this is again based on some feedback from subject matter experts from NYPD, but this could be changed. This could be made in any way it best suits the various government bodies, but this is what we did for this project. The weather, again, we created 3 categories: normal, abnormal, and extreme. Traffic events. Traffic events have a big impact on crime. So that's why we created 3 categories on the traffic events: normal, abnormal, and extreme. The crime categories were like what you see here. So these are the various factors that we used for trying to predict crime. For developing the prediction model, we had to do 2 things. One was create a training model, then get a scoring model. I would show you the code that we had, which we ran on Mahout. When we developed the system, Azure ML was really not even out in the market. So this was completely Mahout based. So we ran logistic regressions algorithms here, and we got the various predictors here, 6 of them, all the categories, and we gave it the proper file, and we ran this on Mahout. Same thing for the scoring. We ran this on Mahout, giving this particular commands. So, but the thing is, since this was real time, since data was coming in real time, we had to always update the model. So this was a kind of a limitation of the system. But now, going forward, Azure ML has got a new mechanism by which you could expose a model, a trained model, as a web services API. We want to leverage that feature of Azure ML going forward so that we don't have to retrain the model all the time whenever new data set comes in. But in real time, we could score the data based on how it comes in. So again, a lot of work still remains, and Microsoft in the last 2 quarters have come up with a lot of new technologies that have actually made a huge impact to Microsoft's presence in the big data world. And we want to extend this current system to leverage those new technologies. So let me just take you to how the crime predictions were looking like. Again, this was in Power Q&A, and what you see is we're trying to forecast the probability of crime for a particular time slot. What we're trying to say is what kind of crime can probably happen at what time. And what is telling me, this graph, is from 12 a.m. till 4 a.m. in the early morning, most of the crimes can normally happen. We could kind of fine-tune our query and understand the probability of theft as a particular crime happening at what time. So theft, again, happens mainly from 4 p.m. till about 8 p.m. That's just how it is. That's just what we saw, what our data tells us. There is a more than 17% probability of crime of type theft happening between 4 p.m. and 8 p.m. We could fine-tune our Power Q&A so that it could drill down to the particular week type. We could forecast on which week what kind of crime can probably happen in what location. I will also show you a Power View that we created. So this was a forecast for July 2014. And when we compared this forecast with the current data that's available on the open data site of Chicago, we were pretty good. This looked kind of 30% close, so this was not bad. So the west side of Chicago is not a very friendly place. So what we have done here is, for the 7/5/2014, the geographical location is west side, and let's say the weather is clear. When the weather is clear, these are the kind of crimes that can probably happen in the west side of Chicago. Battery would be the highest, assault followed by theft. Now let's drill down further or slice it on a time slot basis. Now let's say early morning till 4 a.m. in the morning. Theft, assault, and battery happens the most. We could say, now let's say look at 8 o'clock in the morning till 12 o'clock. Assault is more likely to happen. In the evenings, we see narcotics is more likely to happen. So this is just what our data told us, that in the evening time, the probability of people dealing with drugs is way higher than anything else. But theft is more probable to happen in the late nights. We could also drill down with the traffic distance. We would say, if let's say I'll just clear this. If the traffic distance is, let's say, far away from a police station, then these are the kind of crime that will probably happen at, let's say, 12 late night. Meaning, if the location of a particular place is further away from a police station and it's late at night in the evening, there's a possibility that people would be dealing with a lot of drugs kind of activities. So this is what our dashboard was telling us. And again, as I was telling you, that we want to really improvise on this. We want to really collect data on a regular basis. If we can do that, I think our predictions would really work quite well. So we want to extend this. One of the good things about this system is that all the lessons learned, the patterns detected, and the observation made for one city can be used and extended for other cities worldwide. Human beings are human beings. They tend to behave in kind of similar manner, not 100%, but at least 80%. They tend to behave in certain similar manners and do certain things in very similar ways. So we could extend whatever we have learned from the city of Chicago to other cities also. So to summarize, our system can detect, analyze, and predict crime. It can help public governments battle crime better with lowered cost. It is based on Microsoft technology, which can enable it to scale both horizontally and vertically. We can extend this and customize this to meet specific business use cases of various government bodies worldwide. As a next step, we want to extend this system to use the latest Azure technologies. We are a big fan of the Azure ML product, and we have done some internal work with Microsoft at a lot of demos that Microsoft had created for other things. So we want to really extend this project to also include Azure ML. And the other thing that we really want to do is we want to collect data on a daily basis and fine-tune the algorithms that we have come up with. Doing this on a daily basis will enable us to make sure that we have some kind of an understanding of what kind of crimes are actually happening on a daily basis. We could probably launch a consumer version of this platform by coming up with daily crime scores for the major US cities for which data we are collecting. And finally, we would probably come up with an open source version also that would totally depend on the demand that we see from various governments. The platform that we're thinking to develop going forward has a lot of features in the knowledge management layer where we do a lot of entity extraction and to categorize the data accordingly, which would help us to link the data properly with proper content clustering. Lastly, a very shameless plug. I have uploaded, or I have proposed to the Hadoop Summit people that we would like to present this for the Hadoop Summit. We are near 282 votes. We are still in the top 10. If you think this is something that people at the Hadoop Summit would like to hear, please vote for us. That would be very much appreciated. With that, I'll take in the questions. Thank you so much.
All right, DJ. Well, thank you very much. That was very interesting.
Thank you.
I guess you know what time of day that we can go out on the streets or the sidewalk, right?
Yes, absolutely.
If we're in Chicago. All right, so let's see what we have here for questions. If anyone does have any questions in regards to the architecture, how the data works, the technology, anything about that, please feel free to post those right now. We've got a question here in regards to the Twitter data. Someone had a question wondering that they had heard that only about 10% of the tweets actually have location data in it. Is that true? And how do you find that reliable?
Yes, that's very true. Basically, whenever you are accessing data from a Twitter API, there are two ways you could get the location. One is the tweet location, where the tweet was actually coming in from. So for example, I'm DJ Das, I live in the Bay Area, but I might be in New York. So if I tweet from New York, then the tweet will have two information, that this tweet is coming from New York, but DJ Das is based in the Bay Area. So those are two ways by which you could get the location information. But that's true that the tweet that we get from the free APIs, they don't have good location information, and that was kind of something that bothered us quite a lot. So we had to kind of keep collecting more and more information because we only wanted to have relevant tweets with us. So if we kind of found a tweet that didn't have proper location information, we just didn't bother going about with it. We just kind of ignored it. So yeah, that's a good question.
Great. Okay, we had another question in regards to being able to identify the patterns in the data. How easy was that for you to do, or maybe you're still doing it? I guess how do you kind of start at looking for those type of patterns?
Yep. Since we were not the subject matter expert on crime data, we actually didn't know to start with where to start looking. We are the big data professionals who understand big data technology. We know how to analyze data, but we did not know what to look for. So we did take the help of some of the subject matter experts from NYPD who told us about what is it that, or where is it that we should be looking for, what is it that we should be looking for. But going forward, we quickly started to see patterns. We quickly started to understand how it all evolves. And it's an ongoing education. This is something that we will keep on learning. We'll keep on improvising. We'll keep on understanding more and more about crime as time progresses.
Okay, thank you. Getting a lot of excellent presentations. Thank you for the information. Here we go. I'd like to know if you found it difficult to configure the Q&A functionality in the Power BI.
Good question. Yes, I'll be very fair. When we actually started on this project, Power Q&A was in the preview mode or preview release, and we had to take help from Microsoft to make sure that Power Q&A worked. But now the Power Q&A has stabilized quite a bit, and things are much more easier now. There were times when something that we used or some feature set that we used in Power Q&A just went away and none of our charts would work. So we had to redo them again so that it could work in the latest version of Power Q&A. So it was just the matter of timing, but I can assure you that all the projects that we are doing on Power Q&A now, they are quite reliable, they are really working fine, and it's one of the most prominent features of the Power BI toolset.
Definitely. Okay, how did you connect Stream to SQL Server, and how is this caching mechanism designed?
Good. Okay, so when we did this project, we did it in a bit different way, but I'll tell you as to what it is right now, which we have just worked on. Basically using Event Hub as a queue in mechanism, and then using the Storm part of it. So Event Hub would take in real-time data from wherever we are getting it, and then the Sprout would read off the Event Hub, would use the bolt, which would there would be number of bolts that would that we had lined up one after the other, and the last bolt would actually write it down to HDFS after we have processed the data accordingly, and only filter the data as per what is it that we really want to save on the HDFS. So that's how the lineup was. If there is interest for deep technical deep dive, I could have another session where we could actually open up the technical stuff behind it, show you the code, show you exactly what really happened. I'd be more than happy to talk to you about the technical deep dive.
Sounds good. Definitely look into that. All right. Someone was curious about the amount of code that went into the solution. Like how large was the SQL Server? Like how many databases compared to like how much C# code you might have had to write? What's the complexity of the solution?
Yeah. The good thing was that since this was being saved mainly into the HDFS, it was okay. We were collecting about 100 GB of data on a daily basis from all these various sources, and we were all saving it onto the blob, which is the HDFS part of HD Insight. But when we actually do this in real world for any other government body, I think the data would be in terabytes or even petabytes, because based on my conversations with various government bodies, the data set that's not open, and that's really huge, and that's what they want to use the system on. So we are working with Microsoft to make sure that the Azure platform, on-prem or on cloud, is capable of handling that kind of data volumes.
Did you say 100 gigs?
Yeah, on a daily basis when we're doing this project.
Wow, amazing. Okay, yes, we're getting definite people want you back for a technical deep dive. And 3 people will give that a upvote. So we'll definitely have to see what your availability is later on. And when was the Hadoop Summit coming up? What day was that?
That's actually in June, if I'm not wrong. That's coming up in, yeah, June 9th to 11th. Okay.
All right. Definitely, if people enjoyed this session and you're interested in checking out more information, make sure you give DJ some votes here so he can get out there and do that presentation.
Thank you so much, Dan, for that. I appreciate it.
We have another, someone's curious about any thoughts about maybe making this for like mobile devices and extending this solution so people could get it on their phones.
Oh yes, yes. Actually, we do have something on Windows app which I didn't show in this demo, but actually I could show it to you too at some other time. So we created Windows 8 apps, which was a very simple app though, and we just used the Power BI app to actually show this. But it worked very nice. I was very pleased to see that how whatever we had developed for the web could easily be then translated to the Windows 8 apps and on the cell phone too, or on the Surface Pro. So that really worked out.
Okay, great, neat. Okay, I think that wraps it up for the questions. Just a reminder to everyone that the content from this presentation along with the recording will be posted to our BAVC site. So if you go to bavc.sqlpass.org, you will be able to check out the information there, and we'll have links to it, and you can download the content, and the video will be posted on the YouTube channel. DJ, do you have any last parting words, words of wisdom for our audience?
No, first of all, thank you so much. And just wanted to tell you the hardest part of this whole project, it was to categorize the damn data with all common categories for crime. That was the hardest part of the whole project. Everything else was cakewalk when compared to doing the categorization. Yeah.
Well, that's great. Well, thank you very much for your time. I appreciate you doing this presentation. And just a reminder to everyone that there will be a short survey when you close out of the presentation. Just remember to fill that out, and we can give some feedback to DJ and just give us some guidance as to the content that you're looking for. Thank you very much. Thanks again, DJ.
Thank you so much, everybody. Thank you so much, Dan. Thank you so much, Paros.
Have a good day. Thanks, everyone.
Bye-bye.